So let's study a little bit about converting numbers, and let's choose this pen. So always we are going to look at the base. So this is the base here. The base here is 10. That means this is a decimal number. The base here is 2. That means this is a binary number. And always binary numbers come in ones and zeros. For the octal number, the base is 8. For the hexadecimal number, the base is 16, and sometimes hexa numbers comes with letters. So if we see this one, 19A, that means this is a hexadecimal number. So from the shown diagram here, if we want to convert from binary to decimal, we are going to multiply with 2 to the power n. And the power n is the index. Start from 0 to n. If we want to convert from hexadecimal to decimal, we are going to multiply with 16 to the power n. If we want to convert from octal to decimal, we are going to multiply with 8 to the power n. Let's talk about the first example. So this is the type of a question. Here they are giving you ones and zeros. You know from this number, this is a binary number because the base here is 2. And they want us to change it to a decimal number because this is 10. That means they want to change from binary to decimal. And if we want to change from binary to decimal, we are going to multiply with 2 to the power n, or 2 to the power n, which is the index. So we are going to start from here. This is 1, then 0, then 0 again, then 1, then 1. 1 multiply 2 to the power 0. So 2 to the power 0 is 1. 1 multiply 1 is going to equal 1. 0 multiply 2 to the power 1. 2 to the power 1 is 1. 1 multiply 0 is 0. So anything we multiply it with 0 is going to equal 0. 2 to the power 3 means 2 multiply 2 multiply 2, and it will equal 8. So 8 multiply 1 is going to equal 8. 2 to the power 4, it means 2 multiply 2 multiply 2 multiply 2, and this one is going to equal 16. 16 multiply 1 is going to equal 16. Then we are going to sum all of these numbers. So 1 plus 8 plus 16, it's going to equal 25. And don't forget the base is 10 because now this is a decimal number. Let's take another example. We want to change from hexadecimal to a decimal. And you can see here the hexadecimal base is 16 and we have letters, and they want us to convert it to a decimal number because this base is 10. So from hexadecimal to decimal, we are going to multiply with the base number, which is 16 to the power n. So this is C, this is B, this is A. Okay, so we are going to bring the value of this letter from the table. In hexadecimal, we always start from 0 to 9. After 9, we start from A to F. After F, we are going to start with 10 again. So, as a knowledge or from your own mind, you will notice or you will know that A is going to equal 10. B is going to equal 11. C is going to equal 12. So, we are going to change here. C is equal to 12. So 16 to the power 0 is equal to 1. So 1 multiply 12 is going to equal 12, and so on. In 10, we have all the results. So 12 plus 176 plus 2560, it's going to equal this number, and we will not forget that the base is 10 because now it's a decimal number. Let's take another example. So here they want us to change from octal to decimal. And from octal to decimal, we are going to multiply with the base of octal, which is 8, 8 to the power n. So 9, this is 9, we put it here, and this is 4. So 9 multiply 8 to the power 0, 8 to the power 0 is 1. So 1 multiply 9, it's going to equal 9. 8 to the power 1, 8. 8 multiply 4, it's going to equal 32. And after we 9 plus 32, we are going to have 41 to the power, to the base of 10, because now it's a decimal number. So this is for the multiplication. If we want to convert from octal or binary or hexadecimal to decimal, we are going to multiply with the base number to the power n. Let's go now to the division part. So if we want, okay, when you see the cursor, the arrows going down, that means this is a division. So from decimal to binary, we are going to divide the numbers by 2. From decimal to hexadecimal, we are going to divide them with 16. From decimal to octal, they are going to be divided by 8. Let's take an example. So from decimal to binary, we are going to divide with 2. So this is 41, divide 2. The first result will be 20.5. So we have a remainder, which is 0.5. We will remove 0.5, and we are going to put 1 instead of 0.5. After that, we will take only 20. 20, okay? Divide 2, it will equal 10. So there is no remainder, so it's equal to 0. 5, then 10, divide 2, it's going to equal 5. So there is no remainder, so it's equal 0. 5, divide 2, it's equal to 2.5. So there is a remainder, we'll remove the remainder, and we will put instead of it 1, okay? So now again, 2 divide 2, it will equal 1. There is no remainder, so this is 0. 1 divide 2, it will equal 0.5. So there is a remainder. We will remove the remainder, and we will put 1. So now we can stop because we already reached 0. For the answer, you can start from up, 1, 0, 0, 1, 0, 1, or you can start from down, 1, 0, 1, 0, 0, 1. Of course, the base is 2 because now it is a binary number. So if we have a remainder, we will put 1. If we don't have a remainder, we will put 0. This is the division when we want to change from decimal number to a binary number. Let's take now another example. So now we want to change from decimal to hexadecimal. And in hexadecimal, we are going to divide, of course, by 16, okay? So let's take this number. Okay, so when we divide this number by 16, it will give us the full number, okay, the complete number, 77.125. So this number, 125, we are going to take it and multiply it with 16, okay? So the answer is going to be 2. So this is the first answer. After that, we are going to take only 77. 77 divide 16, it will equal 4.8125. So we are going to take 0.8025, and we are going to multiply it with 16, and it's going to equal 13. Then again, we will have 4 divide 16, it will equal 0.25. So here we are going to stop because we reached 0, and we are going to take 0.25, and we are going to multiply it again. You can see the whole process here. We are going to multiply it with 16, and it will equal 4. So for the result, you can see here we have 1-digit number, here 2-digit number, and here only 1-digit number. So because this is hexadecimal, from the table, we can change this 2-digit to a letter. So 13 in table number equal to D. So this is the answer, 2D4, or from down, 4D2 to the base 16, of course, because this is a hexadecimal. So let's talk now about from decimal to octal. And here we are going to divide by 8 the base of octal. So the process is going to be similar when we want to convert from decimal to hexadecimal. We are going to divide the numbers, and we are going to take like 0.25, and we will multiply it with 8. After that, we will have the result until, of course, we reach 0. Then we are going to put the result, and the base is going to be 8 because this is an octal number. So from decimal to octal, the process is similar from decimal to hexadecimal. The difference here only if we want to change from decimal to a binary number. So for the third rules, if we want to convert from hexadecimal to binary or from octal to binary, we are going to take the result from the table. So let's take an example. We want to change from hexadecimal to binary number. So we have this number 431, a base of 16, and you can see here they want binary. So from hexadecimal to binary from the table. So 4 equal to 100. Okay, from hexadecimal, this is hexadecimal, to a binary, 4 is equal to 100. So we will put 100. 3 is equal to 100. 11. So we will put 11. 1 is equal to only 1. So we will put 1. And A, of course, it's equal to 1010. And you can check the table number. So you can see here we have 4 digits. Here we have only 1. Here we have 2. Here we have 3. So all the digits must be equal. So what we are going to do, this is 4. Here we are going to add zeros to the left side of the number until it's become equal. So here we are going to add 3 digits. Here we are going to add 2 digits, and here only 1 digit. Then we are going to combine them all, and the base, of course, is 2 because this is a binary number. In octal, from octal to binary, it will be the same. So you can see here 4 from octal to binary is equal to 100. 3 is equal to 11. And 1 is equal to 1. So 1 is 1 digit, 3 is 2 digit, 4 is a 3 digit. So we are going to add 0 to the left side and 2 zeros to the left side until all the digits are equal. Then we are going to combine them, and we will not forget that the base is 2. Thank you.